Okay, today we're going to finish the 2-6 section, and we're going to talk about compound inequalities with the word or, O-R, okay? So we've already talked about and, so your compound inequalities, all real numbers less than 2 are greater than 6. Okay, so x less than 2, guys, I have an open circle going to the left. X greater than 6, I have an open circle going to the right. That's how you would graph the compound inequality if it is or. So let's work some of these. Okay, so here's a visual. Last time we did a visual with the Venn diagram. So what this is telling us in circle A, I have x is less than 0, and in circle B, I have x is greater than 10. So if we were to graph this, x is less than 0, open circle, going to the left, x is greater than 10, open circle, going to the right. Okay? So when I combine these two inequalities, that's why it's called a compound inequality, there's nothing that they have overlapping. If you look at the Venn diagram, there's nothing in the overlap of the Venn diagram. So when your final graph, you'd have your solution set less than 0 and your solution set greater than 10. So that's why you get the or, O-R. All right, so let's look at some of these. Okay, so let's treat these like two separate inequalities. Let's solve for t on this side. So we need to subtract 8 from both sides. So t is greater than or equal to -1. Over here, we need to isolate t by subtracting 8. So I have t is less than -6. Okay, so when I graph this, I have -1 and I have -6. Make sure your numbers are lined up correctly on that number line. Okay, so for this one right here, t is greater than or equal to -1. Greater than or equal, I'm going to include that -1, and your solution set goes to the right because it's all the numbers greater. T is less than 6, open circle, I'm not going to include -6, and it's to the left. So all real numbers between -6 and -1, but not including -1, are not part of your solution. This is an example how you graph compound inequalities with or. Okay, so let's solve for x on this side. You would divide by 4. So x is less than or equal to 5. Let's solve for our variable x over here by dividing by 3. So x is greater than 7. When you graph this, I have 5 and I have 7. Okay, x is less than or equal to 5. So I'm going to include 5 in my solution set. Less than are numbers to the left. X is greater than 7. I'm not going to include 7 in my solution set, but all real numbers to the right I am, because that's greater than 7. Okay, every solution of a compound inequality involving and must be a solution of both parts of the compound inequality. If no numbers are solutions of both simple inequalities, then the compound inequality has no solutions. The solutions of a compound inequality involving or are not always two separate set of numbers. There may be numbers that are solutions of both parts of the compound inequality. So let's look at this. Okay, write the compound inequality shown by the graph. Okay, because we have a break and there's no overlap, we must use or. Okay, this inequality, x is less than or equal to -8, or this inequality, x is greater than 0. So here's your compound inequality. Okay, we have no break. When there's there's no break in that inequality graph. We must use the word and. Okay, so let's start here with negative 2. Negative 2 is less than, we're not including it because it's an open circle. Put your variable. Right here it's telling you that's 5. 5 is greater than, not including 5 because it's open circle, x. So here's your compound inequality. Now, you could also write this, x is greater than negative 2, and x is less than 5. Either way, I like to see it this way better, though. All right, guys, that's it. Have a good one.